All right, we're on page 17, finishing up section 1.5. So we're looking at solving linear inequalities. Number 4, our best approach would be to find the LCD, which across denominators 5 and 3 would be 15, and make both of these fractions have that same denominator. So 5 to 15 is by 3. So we'd have 21 over 15 times 10x minus 1, less than or equal to, if we want 15 here, it's by 5. So we get 10 times 6x plus 5. Now that the denominators are the same, we simply have to just take the numerator, 21, and distribute it through 10x minus 1, less than or equal to 10 times 6x plus 5. Let's distribute 210x minus 21 less than or equal to 60x plus 50. Subtracting our 60x to combine x's to one side. 150x minus 21 is less than or equal to 50. Adding 21. 150x is less than or equal to 71. Now we divide to isolate the x. We get x is less than or equal to 71 over 150. We then are supposed to show that on a graph, so we show our critical value of 71 over 150. X is less than or equal to, so we're allowed to be on the left side with the equal to producing a bracket at 71 over 150. The interval we build from left to right. So on the left we have negative infinity, so we're going out to negative infinity up to 71 over 150 bracket. As we continue, problem 5, we would start by distributing. 28 minus 7x plus 5x is less than 32 minus 2x. Combining, 28 minus 2x is less than 32 minus 2x. Combining our x terms to one side gets 28 less than 32. We then have no variable left to solve for, and we have to realize that 28 less than 32 is true, which means all real numbers. That means the entire number line works. So if we were to show a graph, we'd have arrows on both ends. Arrows on both ends translate to an interval of negative infinity to infinity. The U-try problem, we would begin by distributing our negative. So we get negative 4 minus x plus 2 minus 3x is less than negative 14. We'd get negative 4x minus 2 is less than negative 14. Add our 2. So we get negative 4x is less than negative 12. Divide both sides by negative 4. When you divide by a negative, you have to switch the direction of the inequality symbol, so we get x is greater than 3. On a graph, we would be on the right side of 3. We would have parentheses because we only have greater than. The interval would be parentheses 3 out to infinity because we're going to the right. The next part of section 1.5 on inequalities is page 18, and we are looking at 3-part inequalities. So if we look at problem 6, we can see that there are 2 inequality symbols with the variable expression inside. We're going to do all work necessary to get x isolated still in the middle. So I would subtract 3 from the middle and both ends. I would get 1 less than or equal to negative 2x less than 5. I would divide everything by negative 2. Dividing by negative 2 requires that these inequality symbols switch. So we get negative 1/2 is greater than or equal to x is greater than negative 5/2. So on a number line, negative 5/2, be careful, is smaller, so should be on the left. Our x is between, so we shade in between. Negative 5/2 has only a strict inequality, so we use parentheses. Negative 1/2 has an equals to, so we use a bracket. The interval would be parentheses, negative 5/2, comma, negative 1/2, bracket. Problem 7, we would start by distributing. So negative 2 is less than x minus 2 times, we're supposed to be distributing, so let's do that. We get minus 8 minus 2x is less than 5. We're going to combine like terms, so negative 2 is less than negative x minus 8 is less than 5. We're going to add 8 to the middle and both ends. 6 is less than negative x is less than 13. We're dividing across by negative 1. That again makes our inequalities switch direction, so we get negative 6 is greater than x is greater than negative 13. On a graph, we put negative 13 on the left side of negative 6. Our x is between, so we go in between, and we do parentheses on both sides. The interval would be parentheses negative 13, comma, negative 6, parentheses. 8. I would start out 8 by producing an LCD of 4. So I would say negative 12/4 is less than or equal to 3x plus 1 over 4 is less than or equal to 12/4, because these are both over 1. Now I can take the top. Negative 12 is less than or equal to 3x plus 1, less than or equal to 12. Subtract my 1 everywhere. Negative 13 is less than or equal to 3x is less than or equal to 11. Divide by 3. No need to switch the symbols this time because we are dividing by a positive. So we get negative 13/3 less than or equal to x, less than or equal to 11/3. So we put negative 13/3 on the left side of 11/3. We shade between because x is in the middle, and they both get a bracket. Our interval would be negative 13/3, comma, 11/3, bracket. The U-try problem, I would do the same. I would say negative 4 is over 1, 12 is over 1, and I'd use an LCD of 3. So I would say negative 12/3 is less than or equal to 2/3 x is less than or equal to 36/3, and the first one is not less than or equal to, it's just less than, so let's correct that. Now I take the top. Negative 12 is less than 2x is less than or equal to 18. Right, let's see. That would be, not 18, 36. Now I got to take the tops. So I divide by 2. So I get negative 6 is less than x is less than or equal to 18. That's where my 18 goes. Right, on a number line, I get negative 6 and 18, shade inside. Negative 6 has strict less than, so parentheses. 18 has an equal to, so bracket. Interval, negative 6, comma, 18, bracket. All right, so that's all for section 1.5.